Hi, welcome to the Shiko SAT review series. And we are working on the unit, statistics unit. And this is the second part of statistic unit probability. And this is the video number 2. So from the first video, we did a brief review about the 4 topics I listed here is the margin error, events operation, conditional probability, and also how to read a contentious table here. And so we did a 10 practice problem in the worksheets. And now today we're just going to continue doing the worksheets. And then at the same time, if you forgot about what is the conditional probability, make sure go back to the video number 1. And in the first, I think 10 minutes, I did a very brief introductions and write out the formula, those things. So try to refresh your memories, okay, if you don't remember that. Okay, so now let me go back to our worksheets here. Okay, so here is our worksheets, and we did, as you can see, we did problem number 10, and we stop at number 10. So let's take a look at number 11 here. Right? So remember, we always want to highlight what is the important information they tell us. Okay, so the problem number 11 show you where do people get most of their medical information. So I have a doctor, internet, magazine, pharmacy, television, or not. So, okay, so let's take a look at the problems here. Let's say the table shows a summary of 1,200 response survey for a question. Based on the table, how many those surveyed get most of their medical information from either a doctor or the internet? Remember, whoa, here is the keyword we find. So let's try to see do a brief review. Do you guys still remember what is the keyword mean? Or means what? Or means union, right? That means you combined both two together. So we say, what is the doctor or internet? So the total percentage will be 0.63 plus 0.13, right? So that will be what? And so this will be 0.76. And the total, I have 1,200, and the 76% of them get their information from doctor or internet. So what you need to do, so you say 0.76 times 1,200, right? So it's kind of like makes sense there. So what is here is 912, right? So that means I have 912 people. They get their medical information from doctor or internet. Okay, so the number 12 here. So we said the member of a city council wanted to assess the opinion of the city residents about converting an open field into a dog park. So the council surveyed a sample of 50, the 50 city residents who own dogs. Okay, who own dogs. So the survey show, that the majority of those sample, they are in favor of the dog park. Which of the following is true about the city's councilors? What is true, okay? Okay, so now let's take a look. Let's use the method of the elimination. Okay, so the first thing here, it shows that the majority of the city residents are in favor of the dog park. Is this true? No, because, we did these surveys, right, in the dog park, right? So not in the dog park, we did this survey for the people who own the dogs. And we did not include the people who do not have a dog, or maybe they have a cat in the survey. So we cannot make a conclusion, say, hey, majority of the city resident, right? So it's not the whole city resident. Okay, and then the part B say, they say the survey sample should have included more residents who are dogs owner. No, we don't have to because we have a 500th owner. That's a pretty good sample size. And include more dog owners will not, change much about your statistical result, okay? Okay, so part C is here. They say the survey sample should have considered entirely of the residents who do not own the dog. Okay, so they said the survey sample should have consist entirely of the residents who do not own the dog. No, we cannot just say the survey, the people don't own the dog. So the random sample should cover every part, every part of the residents, right? So the own the dog, doesn't have dog, have a cat, or have a cat and the dogs, right? So this is not true here. We shouldn't include the sample with people owning without the dog. So the part D is the right ones here. So they say the survey sample is biased. That's correct because you only take the survey, it's not represent the whole city residents. That's correct because you only take the people that own the dog. So the similar problem, they can say, hey, I'm going to the park and the playground and survey the residents there to see how they like certain toys, right? So that probably is like the biased survey also. If you go to the playground and you ask the people, say, what you feel, to change that open field to the playground as well, right? So that is a biased sample also. So just remember when you take a sample, you have to include every piece, every group in the population. You don't have to be 100% check everybody, but you need to sample all the groups covered. So in order to have unbiased samples there. Okay, so now let's take a look at number 13 here, right? So the ice cream and the topping selection. So the table above shows the flavors of ice cream and the topping here. Okay, so each person choose one flavor of ice cream and one topping. Okay, so now here, we want to find the probability. They say, of the people who choose vanilla ice cream, what fraction choose a hot fudge as topping? Remember, when you read the contentious table, which one you put as a denominator? What is the keyword? Off, right? So whatever the followed off. So now here we say of the people who choose the vanilla ice cream. So how many people they choose the vanilla ice cream here? 13. So the 13 has to be on the denominator. So under the vanilla ice cream, what the fraction? Fudge as the topping, so it's 8. So it's 8 over 13 here. Like I always said, those probability problems, the math part is very easy, but when you read, you need to be very careful about about each wording, all right? Okay, so now in here, number 14, a study was done on the weights of different type of the fish in the pond. A random sample of the fish was caught and marked in order to ensure none of them were weighted more than once. The sample contains 150 large bass, of which, okay, so this sample, right? So we have 150 large mouse bass, of which 30 weighed more than 2 pounds. Which of the following conclusions the best support the sampling data here? Okay, so we say this study, all right? So the majority of the fish, okay, let's take a look at what's the problems here, and let's use the process of elimination. They say the majority of the fish in the pond weigh less than 2 pounds. Well, yeah, so we only have a 30% weight more than 2 pounds, right? So you cannot say the majority of the fish, of all the fish. So this study with different type of the fish, right? So we did study different type of the fish. And then after you study, I take a sample. This sample is the largemouth bass. So even the largemouth bass is 30% more than 2, but you cannot say what happened to the other fish, right? So the first one is not right because it is all fish. And then the second one here, they say the average weight of all the fish in the pond is approximately 2 pounds. No, we don't know about that. We just know the large mouths, 30% of them, more than 2 pounds. Okay, so number C here, approximately 30% of all the fish in the ponds, more than 2 pounds. No, we don't know it's all fish because this 30 pounds is only the large mouths. We don't know how many other fish we have, right? So the part D, this is the correct one. Let's see, is correct. So it's approximately 30% of all the largemouth bass in the pond weigh more than 2 pounds. Yeah, that's exactly what is this one to tell you, okay? Okay, so now let's take a look at the 15th here. The 15, they said in the survey, 607 general surgeons and orthopedic surgeons indicate their major professional activities here, right? So here, this is a general surgeon and this is orthopedic surgeon. So this is a total 607. So the 607 surgeons here. So some of them doing the teaching, some of them doing the research. So this is another contentious table. The results are summarized in the table above. Okay, so now let's see the keyword here so we know what we're going to put on what, all right? Okay, so let's say here, if one of the surgeon is selected at random, which of the following closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activities research? Okay, if one of the surgeons here, right? So that means my denominator is we consider all the surgeons here, right? So one of the surgeons, right? So here is the keyword of, right? So I want to find out what is the probability is the orthopedic surgeon who's indicate professional activities research, orthopedic with the research. So it's a what? It's a 74 here. So that's why the answer here is this is 0.1219. So what is the answers here? It's A's here, right? So as long as you capture that keyword, so you will not get confused, right? So the most common mistake is people will say it's a 74 over 193, all right? And because they said orthopedic surgery is research. Okay, so be careful about the off, right? So whatever follow the off, that will be your denominator. Okay, so now let's take a look at number 16 here. So the number 16, this is another contentious table. Like I said, the contentious table is a big part here. So the table above shows the distribution of age and gender for 25 people who enter a contest. If the contest winner will be selected at random, all right, what is the probability? Okay, so now let's see what do we find here, right? So let's say, okay, I'm going to pick one person at random, right? Okay, so what is the probability the winner will be either a female under 40 or male is age 40 or older, okay? So now let's take a look. Also, they said, hey, if the contest winner is like if I choose we select the randoms, right? So that means I context the winners, the whole contest. That's what we choose here, okay? So it's or, right? You see this or. Or, that means union. That means what you add, right? So it's an addition, right? So maybe I don't want to put a plus. People will think it's a positive, right? So this is addition rule. Okay, so let's take a look. So overall, right? So it's 25. Okay, so the first one here is female under 40. Female under 40 is what? It's 8, right? So it's 8. Or, so it's add, so this is or, that is come to here. And the male is what? And the male and the 40 or older, right? So 40 or older, so it's what? It's 2. Okay, so it's 2, so it's 25. So what is the answer? It's 10 over 25. So it's B. Okay, so it's pretty easy, right? Okay, so number 17, I think probably is the hardest one for this whole package here. Okay, so this is an incomplete contentious table. Okay, so this one is trying to summarize the gender is male and the female, right? So that's one variable. And then the handwriting, the handedness, like you are the left hand or right hand here. So let's try to see here, right? Okay, so let's say here there are 5 times as many right hand female students as there for the left-handed female student. Okay, so this is the first statement. 5 more right hand female students. So here, so if your left hand is X, so how many here I have? I have 5 X's here, right? Okay, now let's take a look at the second ones here. So let's say they are 9 times as many right-handed male, and then they are the left-handed. Okay, so male, I don't know how many, so I said it's Y's, right? So male is 9 times, so it's 9Y here. Okay, so now, did you see? So that means in here, so I want to know, so in here total I have 18 left-handed and 122 right-handed here, right? So what do they want to see? What is the probability that a right-handed student select at random is a male, is a female, okay? Okay, so let's take a look. First one, we need to solve it, right? Okay, so now I know that X plus Y equal to 18, right? Okay, then I have 5X plus 9Y equal to how many? 122. So I'm doing let's do the system of equations. So the first one's here, let me multiply by 5, okay? So you multiply by 5 here, right? So both right-hand side, left-hand side, so this is 5x minus 5y equal to what? Equal to 90, correct? All right, now you can, I'm sorry here, so this is plus, right? Okay, now we can minus that out, 5x minus out, so this is 4y is equal to what? 32. So what is the y here? Y is 8. Okay, so y is 8. So x plus y, we know, is equal to 18. So what is x? X equal to what? Equal to 10. Okay, so now let's write it. Let me see here. Okay, so we know the x equal to 10 and the y equal to 8, right? So 5x, what is here? This is 50, right? And the 9y, y is 72. Okay, so we finally finished the table. Okay, so now let's take a look at here. Okay, so the reading part here. We said, okay, so let's see here. So which of following is close to the probability that a right-hand side student select at random is a female? Okay, that means I'm selecting a student and its right-hand side is a female. So what I'm looking for, so I'm saying probability. What is the probability this is a female, given that it's a right-hand, right? So that means this happened, right? This is a condition. This happened first. I select a person who is right-handed, right? So if this is right-handed, then what is the female, right? Okay, so now let's take a look. So how do we do this ones here? So we know, so do you remember let's try to do the review about the conditional probability. Everybody still remember like A given B, right? So this will be equal to the PB and the P what? Oh, so this one, they don't let me to write it, okay? So this one's here is a PB, and this is a P, A intersect B. That's right. Okay, so now this is the formula. So let's see here. So this is a probability right-handed. Okay, so this is a probability right-handed intersect female. So everybody still remember what is intersect means, or what is the keyword for intersect? And, right? Okay, so now let's see if we can find our probability. So right-handed, what is right-handed? So this column is right-handed, right? So this column is right-handed, right? So what is that? So this is 122. Okay, so now the top one here. So right-handed and female, right-handed and female. Which columns here? Which one is this one? This is right hand and female, correct? So what is here? What do we have here? It's 50s, right? Okay, so now 50 over 122 is 0.4098. Let's see, what is the answer closest to 1? It's 0.410. It's closest to 1. All right, so we're doing good. So the number 18 is here. Number 18 is kind of like not totally related to the probability part, but it's kind of related to the statistic part. Okay, so the number of the rooftops with solar panel installations in 5 cities, A, B, C, D in the graph. If the total number of installations is 27,500, what is appropriate label for the vertical axis here? So what is it here? Right, so when you do a graph in the statistic, you need to tell people what is here, right? So this is the number of the installations, right? So like, let's see here. So let's say total I have a 27,500. Okay, so let's try to add here the graph. Let's see what do we have. So in here, the total graph here. So we have, first one here is what? Is 9. Plus, the second one is here is what? Is 5. And the third one here is what? Is 6. D is what? Is 4, right? And the E is what? E is between 3 and 4. So let's say it's 3.5. Okay, so E is 3.5. Okay, so I have is 27.5. Oh, Okay, so the total I add up to here, but they tell me the total sales is 27,000. So what I need to do is here, so like 27.5, if you times 1,000 will give you what? 27,500. So I know my units here has to be in what? In thousands here, right? So what is the answers here? This is C here. And in fact, this problem is kind of like a very interested and kind of the important problems, because whenever you look at a graph, right? So you need to be careful about what the units they use here, right? So like in here, you say, oh, only 9 installation, and this is a 5 installation. So like for here, this as if the statistician they did a graph like this without putting any note here, this is not a good graph because it doesn't represent the true things. So the appropriate probably you need to write here, right? So that you need to label that the units was used, right? So don't just put the graph there without the detail. So then you could total mislead the people here, right? Okay, so now let's take a look at number 19 here. Okay, number 19 is also a very interesting problem here. So let's say the data in the table was produced by sleeping research here. Group X consists of 100 people who observed earlier bedtime, and group Y is later owl, they stayed later, right? So it's observed late bedtime. If a person is chosen at random from those who recalled at least one dream, right? Okay, so we have at least one dream. If a person is randomly chosen from who is at least one dream, what is the probability that this person belong to Y? Okay, all right, so at least one dreams here. So that means my probability here. So that means what? This is a group what? I'm looking for the probability group of Y, given that what? At least one dream, correct? Okay, so now I'll use my conditional probability here. So this is a probability at least one dream. Then here, this is a probability at least one dream intersect group Y. Okay, so be careful. Like we say here, what is the intersect mean? The keyword and, right? Okay, so now let's see here. Do we find the probability here? Okay, so here that at least one, that means 1 or 4 more. So where are the at least one? Okay, so that means you are choosing from the overall at least one. So these 4 cells are at least one, correct? Because it's 1 or more, right? So my denominator will be 28 plus 11 plus 57 plus 68. Okay, so now they said at least and the Y group, right? So at the least and the Y group, can you tell me which one is at least and Y? Is what? It's these two, right? Those are the at least and the Y, correct? Okay, so that means it's 11 plus what? It's 68. All right, so this will be 79. And it is 164. So what is the, do we have the answer? Oh, yes, very good here. So it's a C here. Okay, so remember, right? So when you read those type of problems, you need to just be very careful to see what they ask, right? So like in here, we say at least one dream. That means it could be 1, 2, 3, 4, 5 or more, right? So you need to highlight, say, okay, so at least one, that is your condition. So let it happen first. You randomly pick a person, this person is at least one. So it's given that it happen first. What is the probability they belong to group Y? See here. So that's why you put the group Y in the front. That's the probability you're looking, right? So then in here, you don't forget the conditional probability, right? Like we said, in general, the formula for given B's here will be PB and PA intersect B's, right? And remember, intersection means and, right? Union means or, right? Then given means conditional probability, right? Okay, that's it. And we finished this unit, and it's very interesting unit. So I hope now you know how to read the contentious table. And remember what is the keyword here to find here? Off, right? So to find a off, and then most likely you will get the correct number you put on the denominator. All right, so this is very fun, interesting. I really enjoyed the statistics part for the, for those type of problems, very interesting. Like I said, all the maths are super easy, but you need to be very careful. When you read, just be careful and, highlight the key things they want you to find. All right, so that's it. And we finished the statistic unit. So total, we have 4 videos about that, right? So the first 2 is about the summary statistic. And the last 2 is here, we talk about the probability. Okay, so it's a pretty good unit, and every SAT exam, they will cover some of those problems here. All right, so that's it. And you guys have a good day, and I will talk to you in our next unit. Okay, bye.